Peace. So we are going to talk today about a really important concept in chemistry called the mole. Now, the mole refers to a particular number, and the number is highlighted right here. It's 6.0221417 times 10 to the 3. It refers to the number of particles of a substance. So you can see why chemists, if they want to refer to the number of particles, they're not going to be talking to each other and say, can you pass me 6 times 10 to the 23 particles of sodium atoms. They're going to use the mole to represent that number, okay? And it's a really easy concept, and we're going to do a little bit of math with this. So no groaning, please. Okay. It's known as Avogadro's constant. So it's named after this person right here, Lorenzo Romano Amadeo Carlo Avogadro di Corregna di Cerreto. You don't need to know that. It's not important. We will talk about his law, Avogadro's law, when we get to the unit on gases and gas pressure. So I'm not going to talk about that today. If you want to know, so think of a mole as this. A mole is defined as the amount of atoms or particles in 12 grams of 12 carbon. Yeah, it's defined as the number of particles of 12 grams of 12 carbon. So think about 12 carbon or carbon 12, C12. C12 is an isotope of carbon and has a mass number of 12. So if I were to measure out 12 grams of C12, I would have 6.0221417 times 10 to the 23 particles. The word particle, though, can mean one of two things, okay? So what's this? The word particle could either mean okay, yeah, no problem. Go ahead. The word particle could mean either atoms or molecules. So depending on what you're talking about, like for example, if you think about carbon exists as single atoms. But if you think about oxygen is diatomic, so it would exist as a molecule. If you look at glucose does not exist as a single atom. It exists as a molecule. Okay. So Avogadro's constant refers to particles, but particles could either mean atoms or molecules, and you will learn that as we go through this. So if you want to know how many particles there are, the formula is really easy. It's right over here. It's defined as big N, that's the number of particles, is little n, which is the number of moles. So little n refers to the number of moles. Okay, number of moles. So yeah, which is the unit would be just simply MOL. Okay, times that Avogadro's constant, which is written as N subscript A. So let's look at a really simple example. Let's take a look at this one. How many atoms are in 2.50 moles of carbon? So how many atoms are in 2.50 moles of carbon? So it's N equals 2.50 moles.
Can you boost Emily's car?
Times 6, I'm going to round it up to 6.02 times 10 to the 23 particles per mole. Hold on, let me just pause this for a second. Oops. Sorry for the interruption. At this school, there's always an interruption. Okay, so you can see it's moles will cancel out. So moles will cancel out, and you're left with n equals 2.50 times 6.02 times 10 to the 23. So what is that as the final answer? Good. Particles. Now again, the term particle can mean atom or molecule. So if it's carbon, it's going to be atoms. But you could leave it as particles. It's fine. Okay. All right. The math itself, honestly, the math itself is not very difficult. The math itself is pretty easy, actually. Let's look at another example. How many atoms are in 5.50 moles of oxygen gas? Now, okay, so let's look at the same formula. Okay, so n equals 5.50 moles times Avogadro's constant. I'm just going to write part per mole. Again, that cancels out. You're left with particles. So what would that be? How many particles are there? So 5.50 times 6.02 should be 33 point something. Times 10 to the 24 particles, right? The thing is, think about oxygen gas, right? What is the formula for oxygen gas? What is oxygen gas? It's O2. So the question is not asking you about particles specifically, it's asking about the number of atoms. So how many atoms are in one particle? So one particle or two atoms. So in other words, we have 3.31 times 1024 particles, but we have double 6.62 times 10 to the 24 atoms. So in 5.5 moles of oxygen gas, there would be 6.62 times 10 to 24 atoms. You can see that these are big numbers. If you remember the video Clash of the Titans, he was referring to how small these atoms are, and there's like so many atoms in a glass of water. There are more atoms in a glass of water than there are glasses of water in the ocean. That's how many atoms there would be in a very small volume. Because these are astronomically large numbers. And it's easier to say something like a mole of as opposed to these huge numbers. Let's look at the next question. How many moles are there in 6.02 times 10 to the 24 atoms of chlorine gas? This question is the reverse of the previous one. So if we have 6.02 times 10 to the 24 atoms, think about chlorine. Chlorine gas is what? Cl what? Cl2. So one particle is equal to 2 atoms, or 2 atoms is equal to 1 particle, right? So if I have 6 times 10 to 24 atoms of chlorine gas, how many particles would I have? What do you think? We have half as many, right? So it'll be 3.01. Okay? If I had 6.02 times 10 to 24 atoms, then I'm going to have 3.01 times 10 to the 24 particles, because one particle is the same as 2 atoms in this case. So now I can go ahead and figure out the number of moles. What am I looking for in this case? Number of moles. How many moles? Am I looking for big N or little n? Right, I'm looking for little n. So little n would be big N over big N subscript A. So we have the number of particles, which is 3.01 times 10 to the 24. And we have Avogadro's constant, which is 6.02 times 10 to the 23. So what would your final answer be then? Is that? Which one? This is 3.01 times 1024. This is 6.02 times 10 to the 23.
Why do you have to have it again?
Of what?
Like, we always explain 0.2 and it finishes 3.0.
The 3.01 is calculated from this.
Yeah.
Because we're trying to figure out the number of moles. And this is based on the original formula, which is N equals number of moles times Avogadro's constant. Yeah, that's 5 point something. What is it exactly? 3.01 divided by... So what is it? 5 point what? 5.00? Okay, we'll go with that. Okay? Alright. Yep. If you, so 3.01 times 10 to the 24 divided by 6.02 times 10 to the 23 is probably, it's not exactly 5.00. It's probably rounded, so you guys round it off to 5.00? Exactly 5? Okay. Alright. Okay, so let's look at the next question. How many moles of sodium ions are there in 1.0 times 10 to the 23 particles of sodium phosphate? Okay, so what's the formula for sodium phosphate? N3PO4. Okay? Now, we have 1.0 times 10 to the 23 particles, correct? Okay. So let's take a look at how many moles that represents. So we're looking for little n again, right? So little n is big N over big N subscript A. We're told we have 1.0 times 10 to the 23 particles. And that's over the constant, which is 6.02 times 10 to the 23 particles per mole. So you'll be left with just moles. Okay? So what is little n? Should be like 0.1 something. 0.17, is it? Okay. Moles. But that's the number of moles of sodium phosphate. The question is asking us for the number of moles of sodium ions. Okay, does anyone know what happens to an ion compound when you put it in water? It dissolves. It actually splits. So in water, this will split into sodium ions and phosphate ions. How many sodium ions do you think you'll get? Very good. Because if you look at your formula, there's how many sodium? 3. So if I want to know how many moles of sodium there are 3 moles of sodium for every 1 mole of sodium phosphate. So 1 mole of sodium phosphate, so one of these will generate, when they split, 3 sodium and 1 phosphate. So 1 particle of sodium phosphate will split into 3 particles or atoms of sodium and 1 particle or molecule of phosphate. Because we're asked about sodium, then we have to multiply this by, we have the number of moles, then we'll have phosphate. So that's going to give us 0.51 moles of sodium ions. Okay? How many atoms are in 0.50 moles of aluminum sulfate? So what's the formula for aluminum sulfate? Yeah, it's Al2 SO4 bracket 3. Now, how many moles? We have 0.5 moles. So if you don't remember the formula is number of particles is the number of moles times Avogadro's constant. So 0.50 moles would actually be how many particles then? How many particles is 0.50 moles? Well, it should be 3.01 times 10 to the 23 particles. Okay, does that make sense so far? Right, half a mole. So if 1 mole is about 6 times 10 to the 23, half a mole should be 3 times 10 to the 23. But, oh, by the way, how many significant digits should we have in our answer? Yeah, very good. You guys remember this stuff. So it actually should be 3.0 times 10 to the 23, because we have, this has 2 significant digits, okay? But we want to know how many atoms there are, not how many particles, right? Remember, particles can be molecules or atoms. So how many atoms would that represent? Well, how many atoms are in aluminum sulfate? So for aluminum, there is 2. And sulfate has, how many atoms in sulfate? 4, and 1 is 5. Times 3 would be, so there's 15. So the total number of atoms is 17. So the number of atoms then would be the number of particles times 17. So how many atoms would that represent? What is it? Yeah, you could say 50. You could say 51 times 10 to the 23, or you could say 5.1 times 10 to the 24 atoms. That's fine. Okay, so are we okay with how we got this over here? Each particle of aluminum sulfate has 17 atoms in it because there's 2 aluminum from Al2, and sulfate has 5 atoms, 1 sulfur and 4 oxygen is 5, but times 3 is 15. So 1 particle of aluminum sulfate has 17 atoms, so therefore we have to multiply the number of particles by 17 to figure out how many atoms there are. Okay? Alright, now, so far, how's the math? The math is okay? Anything really difficult? We're okay with what 1 mole is? Half a mole, 10 moles. Molar mass. It's an extension of this idea now. The molar mass is written as big M. So big M means molar mass. And it's defined as the atomic mass on the periodic table. You know, on the periodic table, the things have an atomic mass. So it's defined as the atomic mass in grams for 1 mole. So if you look at carbon, right? Carbon has an atomic number of 6, and a mass number of 12.011. So 1 mole of carbon would have 12.011 grams of carbon. So you look at your periodic table, you look at the mass number, 1 mole of that substance would have that mass number in grams. So if you look at rubidium, rubidium is the 37th element, and the mass number of rubidium is 85.47. Okay. So the molar mass of rubidium would be 85.47 grams per mole. Now, what is the molar mass for oxygen? Well, this is a tricky one. On the periodic table, oxygen is got an atomic number of 8 and a mass number of 15.99, right? But remember, oxygen is O2. So the molar mass of oxygen, or the molar mass of O2, would be 2 times 15.99 grams per mole, which would then end up being 31.98. Okay, because oxygen, remember, oxygen is diatomic, right? So it exists as 2 atoms. Okay, what about aluminum sulfate? So we broke down the formula for aluminum sulfur, right? Remember, aluminum sulfate has 2 aluminum atoms, 3 sulfur, and 12 oxygen. If you look at the formula for Al2SO43, you can see there's 2 aluminum, 3 sulfur, 12 oxygen. The aluminum each have a mass of, 26.98? The sulfur on the periodic table has a mass of 32.07. And on the periodic table, the oxygen has a mass of 15.99. So when we add all of that up, we get the molar mass of aluminum sulfate. No, you don't have to multiply the oxygen by 2 because you have 12 of them. Oh, I did not multiply it by 2. I'm sorry. So this has to be multiplied by 2. This has to be multiplied by 3. And this has to be multiplied by 12. I was getting ahead of myself. No, because you have to represent the amount for each atom. Okay? Because otherwise, if you do it that way, then you're saying the amount of aluminum, sulfur, and oxygen is the same. But it's not. You can see there's 2 aluminum, 3 sulfur, and 12 oxygen. Yeah. No. Sorry. So now, Rafi, you messed me up. Okay. Can we just... I had that written down, Rafi. Thank you. So it is, I already have it 2, 3, 12. So it's 2 times this, 3 times this, 12 times this. Okay. I didn't say it? Okay, alright, okay. Oh, I'm sorry. I thought you meant I didn't write it. Yeah, so you can see it is 2 times 26.98, 3 times 32.07, and 12 times 15.99. So what's 2 times 26.98? 53.96. What's 3 times 32.07? And 12 times 15.99? Okay, so now we add that all up. Okay. And we're okay with the, now we're adding it, so how many decimal places should there be in our answer? 2, so we're good. So the molar mass of aluminum sulfate is 342.05 grams per mole. This is going to be really important when we start looking at, like, I'm asking you guys to make, like, solutions. And I say, make me 1 mole solution of something. If you can work out how much you have to weigh out, then you can make the solution. So this is going to be a really important concept going forward. Okay. Let's extend this. We could figure out how much we need of a substance with the molar mass if we, and this actually is supposed to be a little m. Can you make that into a little m, guys? So that's supposed to be little m, which represents mass, is equal to little n. Little n stands for what? Little n is number of moles, and big M is the molar mass. So what this formula says is, if I want to know the mass of a substance, I got to multiply the number of moles times its molar mass. So what would be the mass of 3.50 moles of silicone? So the mass would be little n. Little n would be what in this case? 3.50 moles. And what's big M in this case? Big M is the molar mass. So what's the molar mass of silicon? 28.09 grams per mole. So what would the mass be of 3.5 moles of silicon? 98.32. But how many significant digits should we have? 3. There's 3 here. So 98.3 grams. Okay? So far so good? We're almost done. Easy? Talar? Maybe? What is the mass of, second last question, ladies. What is the mass of 1.5 moles of iron 3 chloride? So iron 3 chloride would be what formula? FeCl3. Okay. So in FeCl3, we have 1 iron atom. And what's the molar mass of iron? What is it?
55.
What is it, Mila? 55.85. And we have 3 chlorine atoms, and each chlorine is 35.45, I believe. Okay. So what does that add up to? Okay, so we have 55.85 plus 3 times 35.45. So what's 3 times 35.45? 106. So if we add that up, what do we get? 150. 156? $162? Yeah, it should be 162.20. Okay, so 162.20 grams per mole. Okay, so now, what's the mass of 1.5 moles? So the mass, little m, is the number of moles times the molar mass. The molar mass we just worked out. So it's 1.50 moles times 162.20 grams per mole. That works out to what? 243.30? Is that right? But how many significant digits should I have? 3, so I'm going to round it off to 243 grams. Okay? Last question, ladies, and then we're done. And then after this, you'll have enough, hopefully, theoretical knowledge to solve all of the questions in chapter 5. So how many moles is 3.50 grams of sodium chloride? What's sodium chloride? Na what? Okay, NaCl. That's one sodium atom with a mass of 22.99, I believe, with one chlorine atom with a mass of 35.45. So that should add up to 58.44. Is that right? Okay. 58.44 grams per mole. That's your big M. So now if we want to know how many moles that represent, we're not looking for the mass now, we're looking for the number of moles. So we're looking for little n. So if the formula is M equals little n times big M, little n then would be little m over big M. So the mass is 35.00 grams, and the molar mass is 58.44 grams per mole. So how many moles would that represent? 0. You can put it just to 4 digits. We can have 4 significant digits in our answer. So what is it? 0.599. So it's 3 digits? How many digits should there be in our answer? So, what is it? 5989. Okay, ladies, that is it. The end.